Hello everyone, welcome to Science 8 class, and I am Teacher Roslyn. I'll be your teacher for today. Our lesson for today is about phase change and particle nature of matter. This is actually our lesson for week 3 to 4 of this third quarter. Okay, so let us have a review regarding matter. So when we talk about matter, what comes first into your mind? Okay. Yes, I know you are familiar with this since you've been hearing this word since your grade 3, grade 4, grade 5, grade 6, grade 7, and here comes grade 8. You are still hearing this word matter. So when you say matter, yes, we can associate it with the word volume. So, we usually say matter is anything that occupies space. And how is that related to volume? Take note that when you were in grade 7, during your mathematics 7, you learned about volume. And you learned that volume is the amount of space an object occupies. You are able to compute the volume of square, rectangle, and triangle, and other objects which have definite shape, right? So, in other words, matter is anything that has volume, or matter is anything that occupies space. So when we say the amount of space an object occupies, that is actually volume. That is why matter is related to volume. And also mass. It is related to mass. So that is why whenever they ask you to define or to describe matter, you always say matter is anything that occupies space and has mass. And whenever you heard of this word matter, you think of this solid, liquid, and gas, because these are the common states of matter. And you also give examples of this matter such as water, ice, like that, because we always think of solid, liquid, and gas. And in addition, or based from the module 1 of this third quarter, we also learned that matter is composed, or it is made up of small particles. So what matter made of is actually particle, or it is made up of tiny particles. Okay, so please add that in your vocabulary about matter, that matter is made up of particles. Aside from it is solid, liquid, and gas, it has mass, and it has volume. So that is for matter. Okay, so let us proceed with phase change. Okay, so let us also have a review regarding phase change. I know that we have already discussed this one, we have already discussed it on the first module, but let us recall what is phase change, since this is one of our topics for today. Okay, so when we say phase change, let us sum it up, or let us summarize what we learned about phase change using the acronym PHASE. Okay, what does P stands for? It is a physical change. So take note that phase change is a physical change. Okay, so when we say it is a physical change, the matter will undergo a certain change in its physical composition. So it is the physical composition of the matter that will change. So, and take note that phase change is a physical change. And for heat, for H, for letter H, it stands for heat. And heat is the factor why phase change occurs. So what is the reason when there is phase change? It is because of the presence of heat. How does heat affect phase change? That is letter A, and that is by adding or removing heat on the object. So adding heat on the object will result to phase change. Removing heat to that object or to that matter is or will result to phase change. What about letter S? S stands for solid, and solid is one of the common states of matter aside from liquid and gas. The solid, take note, is S stands for solid. It is an example of phase or state of matter. And what about E? E stands for evaporation. Okay, so evaporation is a form of phase change. So take note again, evaporation. Evaporation is an example of phase change. One of the processes of phase change. Okay, so again, I repeat, when we are talking about phase change, remember the acronym. Remember the acronym P, H, A, S, and E. Okay, P stands for physical change, H stands for heat, and A stands for adding, S stands for solid, and E stands for evaporation. So, phase change is a physical change caused by heat, by adding, through addition or removal of heat, and example of phase is solid, example of phase change is evaporation. So before we are going to start, let us just familiarize ourselves on the objectives or our objectives or our target after finishing this session. So after finishing this session, you should be able to describe the properties of matter in terms of the space, movement, and the force between particles. And then you should be able to show how physical properties of matter change as it undergo phase change through an illustration. And to relate how phase change affect our daily activities. Okay, so please take note of these objectives since these are important for you to be guided on what are the tasks you need to do, okay, for this lesson. Let's start now with our discussion on our lesson for today. So again, our lesson for today is about particle nature of matter. Before we're going to start with our discussion, I would like you to study the animation or this animation presented on this slide. So I would like you to compare the particles. I would like you to observe the difference on the particles of solid, liquid, and gas. So what are the characteristics, behavior? That's it. Okay, I think I have given you enough time to observe. So let us start discussing your observation. Let us start discussing what you have observed. Okay, so particle nature, when you say particle nature of matter, that is the nature of matter based on its particle, or the nature of particle of matter. So what is this all about? It says here that particle nature of matter shows or states that matter is made up of small particles, and these particles are called atoms. We have already discussed that matter is made of small particles, and as you have observed in the illustration, there are particles that compose matter, and that these small particles or these particles are moving, and they have space between them, and also they attract each other. So that is according to the particle nature of matter. Again, when you say particle nature of matter, this states the nature of matter in terms of its particle. That matter is made up of particles, and that these particles are moving, they have space between them, and they attract each other. So please remember that. Be guided on that idea or on that concept. So let us imagine that you are a particle of matter, and you are inside a room with other particles. What particle will you prefer? Is it solid, liquid, or gas? Okay, so reserve that question to be answered later as we discuss the nature of or the nature of particles of the different states of matter, the solid, liquid, and gas. Okay, so you have a question to answer later. So let us now discuss the particles of solid, liquid, and gas as states of matter based on the nature of their particles. So let us compare. Let us be guided on this on the animation that is being presented on this slide. So as what I have said a while ago, I would like you to answer the question after discussing the particles of solid, liquid, and gas. I would like you to answer this question. If you are a particle inside a room and you are with other people or companion or with other particles, what particle would you be? Would you like? Is it solid, liquid, or gas? So let us describe the particles or the nature of the particles of solid, liquid, and gas based on the arrangement of particles. So you have here the table of comparison. Let us just be guided on this table. So I hope you can follow. So in terms of arrangement of particles, we will focus on the nature of particles of matter, the space, the movement of particles, and the attraction between the particles, as what we have learned on the nature of particle of matter. So if it is solid, what is the space between the particles? Or let us describe the space between the particles of solid based on the illustration. So based on the illustration, it is very close. Okay, while for liquid, it is close based on the illustration, but not that close as solid. And For gas, it's far, but not it is far if you're, as you can see on the illustration. So this actually explains why solid it's hard for solid to compress, because if you're going to see, the space between the particles are very close already, so it's not compressible, as what you have learned when when you were in the lower grades, that solid is incompressible, liquid can be compressed, but it is a little, and gas can be compressed. Gas is more compressible. So if you're going to see the particles, if you're going to study, this is the reason behind of that property of solid, liquid, and gas in terms of compressibility. So again, I repeat, solid cannot be compressed because of the space between the particles of solid. But for gas can be compressed, or it is very much compressible. It's because of the spaces between the particles of gas, which is far from each other. Okay, so that is for the particles, or the particle nature of solid, liquid, and gas in terms of space between particles. What about movement of particles? So in terms of movement, as you can see, for solid particles, it's very slow. Why? Because it has very close space, right? As seen on the illustration again. But for liquid, it is slow, but not as slow as solid. That has something to do, again, with the space, or yes, with the space between the particles. It is slow because the particles are close to one another, as seen on the illustration. But for gas, it is fast. Okay, it's fast because the space between the particles is far, and if you're going to see the illustration, it's really fast. Okay, for the attraction, in terms of attraction between particles, of course, it's very strong. So the reason behind it's very close, because the particles are the attraction between the particles are very strong. And that is, I think, the same is true with your relationship to your family. You are very close to one another. It is because the attraction between you and your parents and your siblings is very strong. Okay, diba? It's like solid tayo, meaning we are very close. Our attraction or our relationship is very strong, like that. Do you have that kind of relationship with your family? I hope so. And with your friends? I hope so. Okay, of course. And for liquid, the attraction between particles is strong, but not that strong if you compare it with solid. That is being as shown by the space between particles. And then for gas, the attraction is weak. That is why the space between the particles is far, because the attraction is weak. And that the result, they can move freely, or they can move, or they can go the same with a person. They can go wherever they want to go if they have this weak relationship with other people. Yeah? They are just like these gas particles. Okay, so this time I would like to, based on this particle nature of matter for solid, liquid, and gas, I would like to go back on my question a while ago, that if you are a particle and you are with someone inside the room, what particle would you like to be? Is it gas particle, solid particle, or liquid particle? Okay, so I would like you to share your answers. I would like you to share your answer in our group chat. Maybe later, if I'm going to ask you again the question. Okay, so please think of that question as a critical question, and try to imagine yourself as a particle. What would you really be, or what you would want to be? Is it a solid particle, a liquid particle, or a gas particle? Okay, so that question is for you to answer, for you to think about. And then please inform your answer through our group chat or through PM. Thank you. Okay, I will very much appreciate if you will answer that question. Okay, so we are already done discussing about particle nature of matter and phase change. This time we are going to relate phase change and particle nature of matter. So the question that we are going to answer here is that, will there be a change if phase change will occur? Or I mean, will there be a change in the nature of particles of solid, liquid, and gas if they will undergo phase change? Okay, so before we are going to relate these two concepts here, let us just have a brief discussion on the different processes of phase change. Well, I know you are already familiar with the different phase change or different processes because you have been encountering these terms when you were in the lower grades. Okay, so just a brief discussion on it only. So from this illustration, when solid changes to liquid, how do you call the process, or what change will occur? What change or what phase change or process of phase change will occur? Yes, it is melting. But what if liquid will change into gas? So how do you call the process? Okay, what process of phase change is it? It is evaporation. Correct. And what if gas changes to solid? Okay, so from gas it will change to solid. The process is deposition. Okay, the term there is deposition because there's a formation of deposit. So from the word deposit, then the process, the formation of deposits or solid deposits, so it is deposition. Okay, so let us reverse it. What if solid, this solid here, changes to gas? Okay, so the other way around. So solid will change into gas. How do you call the process? It is sublimation already. It's not deposition. It's sublimation. Okay, and what if this gas here will change into liquid? Okay, the process is already condensation and not evaporation. It's already condensation. Take note of that. So from gas to liquid, gas phase changes to liquid. The process is condensation. And what if liquid will change into solid? Okay, so liquid will change into solid. The process is now freezing. So freezing. So take note of the different processes. So again and again, solid to liquid, that is melting, and then liquid to gas, that is evaporation, and then gas to solid, that is deposition. Solid to gas, that is sublimation, and then gas to liquid is condensation, and liquid to solid, that is freezing. Okay, so those are the different processes of phase change. So we have melting, evaporation, deposition, sublimation, condensation, freezing. Okay, so let us see if matter undergo phase change, what will happen to the nature of the particle. So let us discuss it one by one so that we can be able to describe it, what will happen to the nature of the particles if solid will change into liquid, liquid will change into gas, and gas will change into solid, or the other way around. Okay, so let us discuss first melting. For melting process, how do we describe again melting? When solid changes to liquid, we call it melting. And what will happen to the particle of solid if it will change into liquid? Well, as you can see in the illustration, it really changes. So the particle nature of matter or of solid will change into liquid if it will change into liquid. It follows. So if you are going to see the illustrate idea table from solid, here from solid, it will change into liquid. So what will happen to the nature of particles in terms of arrangement? Okay, so for space between particles, of course, from solid, which is very close, it will then become close. Okay, the space will close to each other, but not as close as before. And movement, in terms of movement, of course, from solid, which is very slow, it will become slow. Well, this is still slow, but not as slow when it was solid. In the solid phase, when the matter is in the solid phase, it is not as slow. It is not as slow as in the liquid phase already. And in terms of attraction between particles, of course, when it was in the solid phase, it is very strong. The attraction between the particles was very strong, but as it turns into liquid, it will be strong only. Okay, so that is the change. So as a solid changes into liquid, the nature of particles of this solid will also change into liquid. So that is the concept there. Okay. So what about if during the process of evaporation? So from liquid it will change into gas. What will happen? Let us see. Okay, so let us see during the process of evaporation. So we know very well that when liquid changes to gas, yes, the process is evaporation. So what will happen to the particle nature or the nature of particles of liquid as it changes to gas? So as you have seen in the illustration, it will change. So the nature of particles from liquid, it will change into the nature of particles of gas already. So if we are going to see the spaces between particles, it's from close to far already. And in terms of movement of particles, it will become slow to fast. And for the attraction of particles, it will be from strong to weak. Since the matter or the objects or the matter changes from liquid to gas. So, if it will change into gas, then it will follow the particle nature of gas. So that is actually the idea there. So we are already done with evaporation. This time, let us proceed to deposition. Let us just follow Mr. Smiley. Okay, so from evaporation, let us proceed to deposition. Let us see also what will happen to the nature of particle of matter as it changes from gas to, from gas to solid. So let us see for the process wherein gas changes to solid, what will be the process? Again, it's deposition. So what will happen to the nature of particle of matter as it undergoes deposition? As you can see on the illustration, it will change from the nature of gas particle to solid particle. So for the table of comparison again, let us see. In terms of space, of course, since it changes from gas, so it is from far to solid, which is very close. And in terms of movement, from fast, it will become very slow already, following the nature of particle of solid. And in terms of attraction, from weak, it will become very strong. So the nature of particle, the movement or the attraction of particles between particles is already very strong since the matter changes to solid. So from deposition, here comes again Mr. Smiley reminding us that let us proceed to sublimation. So we're done with deposition. This time, let us see if we are going to reverse the process. So a while ago, we started from solid to liquid, liquid to gas, and then gas to solid. This time, let us start with solid to gas. So the process, what if solid will change into gas? Or what if the change is from solid to gas, or the process is sublimation? Will it be the same? Let us see. So let us have now the next process, which is what if solid will change into gas? So the process there is sublimation. What will happen to the particles? Okay, so as you have seen in the illustration, since it will change from solid to gas, so from solid particles it will change to gas particles, therefore the nature of particles will also change. So again, be guided on the table. So what will happen to the space, to the movement, and to the attraction of particles? Of course, it will change. So from solid, it will change to gas. So the space will change also from very close to far. The movement of particles will change also. So from very slow to fast. and from very strong to weak attraction. So the same. It will still affect the nature of particles of matter or of that particular matter. Okay, so we're done with sublimation. This time we will proceed to, oh, here again is Mr. Smiley. Hi. He's reminding us that we will proceed to condensation. So, for condensation, that is gas to liquid. Let us see if there will be a change. Will it be the same? Okay, so gas changes to liquid. That is, again, condensation. And let us see if there will be a change. So from the illustration, gas will change into liquid. So based on the particles, from gas particles, it will become liquid particles. So of course, it will change. The nature of particles will change. So let us see again. And so in terms of space, in terms of movement, in terms of attraction, from gas, right, to liquid. So from far, it will be close. And then in terms of movement, from fast moving particles to slow moving particles. And in terms of attraction, from weak attraction to strong attraction. Yes, strong attraction. Okay, so that's it for condensation. So again, since the matter changes from gas to liquid, then it will also, the nature of the particles will also change. Okay, so we're done with condensation. What's next, Mr. Smiley? According to him, we are now in the freezing process. Hey. Okay, so what if liquid changes to solid? So the process is freezing. What will happen to the particle nature or the nature of particles of liquid if it will change to solid? Let us see. Will it be the same? Okay, so if liquid changes to solid, and that is freezing, the particles will become like this. So from liquid particles, it will become solid particles. So again, let us see the comparison. So from space, in terms of space, I mean, and in terms of movement, in terms of attraction, of course, it will become far to very close, since the particles changes to solid. And from slow, it will become very slow, and then strong, it will become very strong. Okay, so the same with the other processes, it will change. It will follow the nature of matter that where it changes. So if it changes to solid, then it will follow the nature of solid particles. If it changes to gas, then it will follow the nature of gas particles. If it changes to liquid, then it will change. It will follow the nature of liquid particles. Hey, the discussion is already over. Here now it's your turn. So I would like to know what have you learned, or did you learn something? I hope so. So let us try to answer the prepared activity. Let us read the paragraph, and then let us complete the thought of the paragraph by underlining the correct answer or correct word inside the parentheses. Okay, this one's here. So let us choose what words or word are we going to underline or to choose in order to complete the paragraph correctly. So I will read it for you. Read it with me. Matter is made up of tiny particles. The arrangement of particles depends on their phase and it lies on the spaces between them, their movement and attraction between particles. In terms of spaces between particles, solid particles are very close, close, or far particles. Liquid particles are, is it very close, close, or far? While gas particles are very close, close, or far from each other. What do you think? Are the words to be underlined in order to complete the thought of the paragraph? Okay? Okay, jot down your answers. Let us see. So, it is supposed to be, in terms of spaces between particles, solid particles are very close particles, and liquid particles are close, while gas particles are far from each other. So again, in terms of spaces between particles, solid particles are very close with other particles. Liquid particles are close, while gas particles are far from each other. That is according to the particle nature of matter. Okay, what about this paragraph here? Gas particles move very slow, slow, or fast, while liquid particles move very slow, slow, fast, and solid particles move very slow, slow, or fast. What do you think is the correct answer? Okay, let us continue reading the paragraph. The attraction between particles of solid is very strong. Is it very strong? Strong or weak compared to liquid and gas? Okay, let us compare your answer. Did you get the correct answer? So, gas particles move very slow, while, is it very slow? No. Gas particles move fast, while liquid particles move slow, and solid particles move very slow. Right? The attraction between particles of solid is very strong, yes, compared to liquid and gas. So that is according to particle nature of matter. Did you get the correct answer? Yes, I hope so. So if you get the correct answer, then you really listen to our discussion, and congratulations to you. Okay, it's your turn. So let us see if you really listened or if you really understand our discussion. I would like you to do the task given on the activity sheet handed to you, then submit it to me after you're done. Okay, so do not forget to review your answers before before you submit your paper. Yes, yay! I know you can do it. Okay, so let us apply what we have learned from our lesson to real life situation. So actually, I'm giving you a situation here. Please study it, but I will tell the situation actually. Okay, so the situation here is that a drop of water is watching the wind as it moves, the trees, the leaves of the flowers, the leaves of the trees and the grasses, together with a block of wood. So they are actually watching the wind. And then suddenly, the drop of water uttered, "I wish I have the particles of the wind, so I can move fast." And then the block of wood answered, "At least you are flowing. Look at me, water. I can't even move." Okay, so that is also the claim of the block of wood. So if you are there, what will you do so that instead of having this conversation, they are actually having self-pity because for water, it cannot move fast like the wind, and for the block of wood, it cannot move. So what will you say to them so that instead of saying this or having this conversation, they will say, for water, will say, my particles may not be the same with the wind, but at least I'm flowing. And for the block of wood, I may not move like the wind, but I still have the particles I am made up of. So, what are you going to tell to the droplet of water and to that block of wood so that instead of having the first conversation, they are going to have this second conversation. So what advice you can give? I would like you to write your answer at the back of your activity sheet and then submit it to me together with the activity that you had a while back. Yes? Yes, I know that you are a good advisor. You can be able to convince the droplet of water and the block of wood to be satisfied of what they have. What are you going to say or what are you going to tell them? I'm excited to know your answers, so please write the best answer that you can give. Yes? Okay. Okay, so that's all, folks. See you again on the next session. If you have questions, please do not hesitate to ask through our group chat, through Messenger, PM me, text me, or call me. Or please ask me to call you. I am very much willing to help if there are questions you need to ask or clarifications you want to tell or you want to relay. Thank you. Teacher Roslyn, signing off.